All right, we come to the final performance task for this course. As you can tell from the picture, it's going to deal with triangles. You should have been able to tell that from the chapter as well. We're going to be looking at analyzing triangles and classifying them by the lengths of sides, by the angles, and then finally proving that triangles are congruent or not congruent. Remember, congruent is the geometry or geometrical way of saying that something is the same or equal. So, quickly we'll go through this task so that you have a good understanding of what you'll need to do and how it's going to be evaluated. I urge you again to check the rubric to see what levels of performance you want to reach and what you need to do to reach those. So, in this, we're going to be looking at putting a triangle onto a coordinate grid. Again, supplies you need, graph paper, rulers, all those things are located on my desk. So we want to plot this triangle, and then after plotting the triangle, we want to find the length of each side using the distance formula. This triangle is going to be a bit unique in that the base, when you plot it, is going to be a horizontal line or a straight line going perfectly straight across with no change in rise over run. For that horizontal line, you can simply count the units to get the length of that side. Then you want to determine, based upon those side lengths, is the triangle equilateral, meaning all sides are the same? Is it isosceles, meaning that two sides are the same? Or scaling, meaning that no sides are the same? Um, then you want to calculate the angles. I know the instructions say to use the law of cosine. We're just looking to see if it's an acute, right, or obtuse, so we don't need exact measures of angles. You can use a protractor in all of these examples to measure angles and see if any of them are right angles, obtuse, or if they're all acute, which this triangle is that I drew. The second thing you're going to do is you're going to perform a reflection. You're given the point of reflection. You're going to plot the new triangle, and then you're going to prove using one of the methods uh, provided here in part 2 that the triangle that you created and the original are congruent, and show the calculations to make that proof, whether it be side lengths or angles. Um, this one you'll end up with the same side, so you're going to be using sides, and then you can go from there. And then you need to be able to explain why the reflection ensures congruence and preserves the same triangle. Think back to what a rigid transformation is. That might help you in answering that question. You're finally going to plot a third triangle that's not going to be connected to the first two. It's called the mountain triangle. You're given new coordinates. You need to again verify uh, that it is isosceles by calculating the lengths of the two sides that aren't horizontal. Then you want to prove that it is not congruent to the original triangle you started with using side lengths and angles, and explain why it's not congruent, and again classify it again as being acute, right, or obtuse by calculating one angle. Again, I'm not going to ask you to identify the exact angle measure. You can use a protractor If you want to try using the law of cosines, I can go over that with you. It's really simple. It's just a ratio using the side length and angle measures, and we can go from there, or side length and side length. Going on here. The last point is something that we're just introducing in this section. It's something that we'll cover later on. Um, is to find the centroid of the triangle. The centroid is actually the average of the x values and the y values of the vertices. It's a point that is sort of the balance point of the triangle. This is an important thing to think about. Just to give you a significance of a centroid, let's say you have a town with 3 hospitals that sort of form a triangle, and you want to locate an ambulance station that's easiest to get to all 3 of those. You would use the centroid, which is a average of all of the lines that go from bisectors and something like that, and you would find the centroid. You'll find more about that and explain why that's a reasonable choice to put the treasure. Hopefully that wasn't too much of a hint that I just gave you. Your final thing, you'll have a completed graph paper with all of the triangles plotted, the treasure location identified and marked. You'll provide all your calculations for side lengths. Again, you can use angles and just show that you measured it with a protractor, and calculations for how you calculated the centroid. You need explanations for each of the things that you have. As a bonus, if you want to do it, is you can rotate that last mountain triangle counterclockwise around the point 4 and 10 and plot that triangle, and if you do that you'll get some extra credit. I don't know what it'll be. If you're going to attempt that, I don't know if I have it, but between myself, Mr. Repke, Mr. Hines, somebody has some hamburger sheets that are transparent that you can use to make that rotation pretty easy if you want to try that. Again, be sure to consult the rubric. Make sure that you get everything completed to get to the levels of performance you want. Ask for questions or help if you need them, and good luck.